We're going to explain how to resolve the database is locked error in SQLite3 when using Python and Django. This frustrating error typically occurs when multiple processes or threads try to access and modify the same SQLite database file simultaneously. SQLite, unlike many other database systems, doesn't handle concurrent writes well by default. Let's explore several solutions. 1. Understanding the problem. The core issue is that SQLite uses file locking to ensure data integrity. When one process holds a write lock, other processes attempting to write are blocked until the lock is released. This leads to the database's locked error. In a Django application, this might happen if you have multiple requests trying to update the database concurrently, or if a long-running background task is holding the database lock. 2. Using threading and connection pooling for Django. Django's default database backend for SQLite doesn't handle concurrency efficiently. Switching to a connection pool, like the one provided by DjangoDB Con Pool, significantly improves this. A connection pool manages a set of database connections, allowing multiple threads to access the database concurrently without constantly acquiring and releasing locks. Installing the package, pip install DjangoDB Con Pool, and configuring your write single quote settings.py write single quote to use it is essential. This often resolves the issue by preventing multiple threads from fighting for the same connection. 3. Implementing transaction management. Ensure that all your database operations are wrapped within database transactions. A transaction is a single unit of work, ensuring that either all changes are applied or none are. In Django, you can use the atomic decorator or context manager. This helps avoid long-held locks and improves concurrency. For example, using with transaction.atomic, around your database queries guarantees atomicity, and if an error occurs, any partial changes are rolled back, releasing the lock. 4. Checking for long-running processes. Identify and optimize any long-running background tasks or processes that interact with your database. These could be holding on to the database lock for an extended period, blocking other processes. Breaking these tasks into smaller, more manageable units can significantly reduce the lock contention. Consider using asynchronous tasks or Celery for more efficient handling of background operations. 5. Switching to a more robust database. While SQLite is great for smaller projects, it's not ideal for high concurrency environments. Consider migrating to a database system like PostgreSQL or MySQL, which are designed for concurrent access and offer better performance and scalability under load. These databases have robust concurrency controls built in, eliminating the database's locked issue more reliably. 6. Debugging and logging. Use proper logging to track database operations and identify which processes are holding the locks. Tools like Strace, Linux, can help pinpoint the source of the lock contention by showing system calls. This detailed analysis is key to finding and resolving the root cause. Remember to only use these tools carefully, as they can reveal sensitive information. By carefully examining the logs, you'll pinpoint the specific queries or tasks causing the problem. This detailed debugging often uncovers unforeseen issues and improves the overall application stability.